Hello everyone, it's lecture 15 in Algebra by iTunes Academy Matrices and Linear Systems, and we will deal with linear systems by two methods. The first by Gauss reduction Jordan method, and here the second by inverse matrix method. So let's start with Gauss Jordan reduction method. If I have this two linear equation in this form, here I have x minus 3y equal to here 7 and here 4x plus 5y equal to 45. Okay, by the concept of multiplication of matrices, I can rewrite this linear system in this way. So I can write here the coefficient of the variable x and variable y. So I have here 1, negative 3. Here I have 4, here 5, and here x, y. If I multiply these two matrices, okay, I will obtain this matrix. So I have here x minus 3y, and here I have 4x plus 5y, and this equal to here from the system, this equal to 7 and 45. Okay, so here if I name this matrix A and the matrix of three terms P, so here I can write linear system in this form: matrix A of the coefficient of variables into matrix of variables, okay, equal to three term. Okay, so here A into x equal to B. Okay, so by if I have this system matrix AX equal to B by using Gauss-Jordan reduction method, and only by two steps I can proceed the solution of linear systems. Okay, here the first step is to form matrix by coefficient of x in order here x1, x2, x3. Okay, and by free term b. Okay, then if I have this system AX equal to B, I will form this matrix. If I have two equations, then I have here from A, A1, A2, A3, A4, okay, and here I will put P1, P2, okay, in this form. The second step is to perform row operation as we learned before to convert the part of matrix A into identity matrix. So I will get here this A1, A2, A3, A4 will convert into identity matrix. So I will obtain here 1, 0, here 0, 1, and part of 3 term here will convert it to my variable. So here I will obtain the value of x1 and here the value of x2. Okay, just in two steps I will proceed the solution of system linear system. Okay, so let's remove that and move to the first example. The first example is to solve using Gauss-Jordan reduction method this system of equation. Here we have negative x1, here we have minus 2x2 equals to negative 13, here 4x1 plus 6x2 equal to 0. Okay, so let's start with our steps. Okay, the first step is to for matrix of coefficient and three terms. So we have here negative 1, here negative 2, here 4, 6, and the three terms are 13, 0. Okay, second step is to perform row operations, and here we have negative 1. So the first operation is to divide first row by negative 1, then multiply first row by negative 4, then add to second row. So we will have here we have divide by negative 1. So we have here 1, 2, 13, multiply by negative 4 and add to second line. So we have here 0, multiply 2 by negative 4, add to 6. So we have here negative 2. Here multiply by negative 4 and add to second row. So we have here negative 52. Okay, again with here second row we have here negative 2. So simply we will here divide by divide by negative 2, here multiply by negative 2, then add to first row. Okay, so we will have here here we will divide by -2, so we have here 0, 1, and here 26. Here multiply by -2, then add to first line, so we have here 1, here 0, and here -39. So after we will obtain here, we will have here x1 and x2, so x1 equal to -39, x2 equal to 26. Okay, let's move to another example. Second example, here to solve by using Gauss-Jordan reduction method, we have here this system 2x minus 3y plus 2z equal to 14. Here 4x plus 4y minus 3z equal to 6. Here 3x plus 2y minus 3z equal to -2. Okay, so simply with our steps here, first step is to form matrix here by the coefficient of x, y, and z. So we have here 2, -3, 2. Here we have 4, 4, -3, and here 3, 2, -3, and three terms are 14, 6, -2. Okay, so second step is to perform row operations. So here with first line plus the first operation is to divide by 2. Okay, first row. Okay, again multiply first row by -4 to make 4 equal to 0. Add here to second row again to make this 3 equal to 0. So multiply by here -3, then add to third row. Okay, let's perform this. We have here 1, -3 half. Here we have 1, and here we have 7. Okay, multiply first row by -4, then add to second row. So we will have here 0, and then multiply -3 by 2 by -4, then add to 4, we will obtain here 10. Okay, multiply 1 by -4 and add to -3, we will have here -7. Multiply 7 by -4, then add to 6, we have here -22. Okay, multiply first row by -3, then add to third row, so we will have here 0. Multiplied here by -3, then add to 2, we will obtain here 13 by 2. Here, multiplied 1 by negative 3, then add 2, negative 3. We will have here negative 6. Multiplied 7 by negative 3, then add 2, negative 2. We will have here negative 23. Okay, so same operations with second row. Okay, so we have here, we will have here 10. Okay, so first divide second row by 10. Okay, here multiply second row by 3 by 2, then add to first row. Here we have 13 by 2, so here multiply second row by negative 13 by 2, then add to third row. Okay, let's perform that. So we will have here 1 0 0. Here we will divide by 10, so we will have here 1 negative 7 by 10. Here negative 22 by 10. Multiply second row by 3 by 2, then add to first row, so we will have here 0. Multiply negative 7 by 10 by 3 by 2, then add to 1, so we will have here negative 1 by 20. Multiply negative 22 by 10 into 3 by 2, then add to 7. We will have here 37 by 10. Okay, again with third line, multiply second line by negative 13 by 2, then add to third line, so we will have here 0. Here multiply 6 by negative 13 by 2, then add to negative 6. We will have here negative 29 by 20. Multiply this by negative 13 by 2, then add to negative 23. So we'll have here negative here 87 by 10. Okay, so again with third row, we have here negative 29 by 20. So first operation here and third row is to divide by negative 29 by 20. Okay, here we have here negative 7 by 10, so multiply third row by 7 by 10, then add to second row. Here last one to multiply here third row by, here we have negative 1 by 20, so we'll multiply by 1 by 20 to eliminate negative 1 by 20, then add to first row. Okay, so let's proceed this. So we will have here this. Okay, here we have 1 0 0, here 0 1 0. Here we will divide by negative 29 by 20, so we'll have here 1, and here we will have 6. Here multiplied 1 by 7 by 10, then add to second line, so we'll have here 0, multiplied 6 by 7 by 10, then add to negative 22 by 10, so we will have here 2. Again multiplied 1 by 20, so we will have here 0. If we add to first line, multiply 6 by 1 by 20, then add to 37 by 10, so we will have here 4. Okay, we just obtain here this part as identity matrix. Okay, so here x equal to 4, here y equal to 2, z equal to 6. Okay, I hope this is clear, and move to another example. Again, asked to solve by Gauss-Jordan reduction method. Here I have this system: 3x plus 5z equal to 14, x plus here 4y minus 2z equal to negative 10, x plus y plus z equal to 2. Okay, so let's start with first step to form our matrix with the coefficient of x, y, and z and the free term. So we have here 3, 0, 5. Here we have in second equation 1, 4, negative 2, 1, 1, 1. And the free terms here we have 14, negative 10, 2. Okay, so let's proceed our row operation in second step. So here first we will divide first row by 3. Okay, then multiply first row by negative 1, then add to second row, again multiply first row by negative 1 and add to third row. Okay, so here if we multiply or divide by 3 and first row, we will obtain that 1, 0, 5, third, here 14 by 3. If we multiply the first line by negative 1 and add to second line, so we have here 0 and here 4. Here we will have negative 11 by 3, again 14 by 3, here and 2 negative 1, here minus 10. We will obtain here negative 44 by 3. Again with third line, multiply first row by negative 1, then add to third line, so we have here 0. Here we have 1 and here 5. third by negative 1 plus 1, we have here negative 2 thirds, and here we will obtain negative 8 by 3. Okay, so we have here 1 0 0. So again with second row. Okay, okay, we have here in second row 4. So the first step is to divide second row by 4. Okay, then multiply second row by negative 1 and add to third line or third row, and no need of operations in first row as we have here 0. So just we will just obtain here 0. Okay, so let's start from the first one here. I have here 1 0 0 and will multiply or divide by 4 in second row. So we have here 1 negative 11 by 12, here negative 44 by 12. Okay, and first line 0 by third 14 by 3. Okay, so here multiplied by negative 1 and add to third row, we have here 0 multiplied by negative 1 and add to third row. So we will obtain here quarter multiplied by negative 1 and add to third line. So we have here 1. Okay, again we have here 0 1 0. Okay, so just again with operation on third row, here we have quarter. So the first operation is to multiply by 4 third row. Okay, after that multiply by 11 by 12, then add to second row, again multiply by here negative 5 by 3, then add to first row. So we will obtain here 0 and here 0. Okay, so let's start. This will equal to, here we have 1 0 0 0 1 0, and here if we multiply by 4, here we have 1 and here we have 4. So here multiply by 11 by 12, then add to second line. So we have here 0 multiplied by 11 by 12, then add to second line. So we will have here 0. Okay, multiply by negative 5 by 3 and add to first line. So we will have here 0 multiplied 4 by negative 5 by 3, then add to 14 by 3. So we will have here negative 2. Okay, so we have here x equal to negative 2, y equal to 0, z equal to 4. Okay, I hope this is clear and simple to proceed steps of Gauss-Jordan reduction method. Okay, second method is inverse matrix method. So if we have this system AX equal to B system of matrices, so here X from here will equal to inverse of matrix A into matrix B. Okay, so if we have here matrix A, A1, A2, A3, A4, this matrix 2, 2, and here x1, x2 is equal to here p1, p2, then here x1, x2 here will equal to here inverse matrix of A and 2 here b1, b2. We have here this matrix 2, 1, and here b 2, 1. So the matrix, the resultant matrix of this multiplication will be 2 into 1 in dimension. Okay, let's remove and start with an example. Here we have to solve using inverse matrix method. So here we have this system of linear equation x1 plus 2x2 equal to 4. Here x1 minus x3 equal to negative 15, and here negative x1 plus 3x2 plus 2x3 equal to 4. Okay, so here we have matrix A equal to here 1, 2, 0, here 1, 0, negative 1, here negative 1, 3, 2. Okay, matrix B equal to here 3 terms, 4, negative 15, here 4. Okay, so just we will get inverse matrix of matrix A, just as we know from previous lecture of operation on matrices. Just augment matrix A with identity matrix with same dimension. Okay, so here just here 1, 2, 0, here 1, 0, negative 1, here negative 1, 3, 2, and here identity matrix 1, 0, 0, 0, 1, 0, here 0, 0, 1, identity matrix with dimension 3 and 3. So here we have first row 1, 2 0, here 1 0 0, and here multiply first row by negative 1, then add to second row, so we will have here 0, negative 2, here negative 1, here negative 1, here 1 0, here add just first row to third row, so we'll have here 1 5 2 1 0 1. Okay, here for second row, just we have here negative 2, so first operation to get this number 1, so here divide by negative 2 second row. Okay, and here multiply by negative 2, then add to first row, again multiply by negative 5, then add to third row to get rid of 2 here and 5 here. Okay, so just 1 0 0, divide second row by negative 2, so we have here 1 1 half 1 half, negative 1 half 0. Okay, and for the first row just multiply second row by negative 2, then add to first row, so we will have here 0, here we will have negative 1, here we will have 0 1 0. Okay, and for third row multiply second row by negative 5, then add to third row, so we'll have here 0, here we will have negative 1 half, here negative 3 by 2, here 5 by 2, and here the last one is 1. Okay, again let's enlarge our bracket. So here for third row we have here negative 1 half, so just here divide by negative 1 half. Okay, we have here 1 half, so multiply the row by negative 1 half, then add to second row. Okay, here we have negative 1, so just add third row to first row. Okay, so just we have here 1 0 0, here 0 1 0, and here we will divide by negative 1 half, so we have here 1 3 negative 5, and here negative 2. Okay, here multiply by negative 1 half, then add to second line, so we will have here 0, multiply by negative 1 half, then add to 1 half, so we'll obtain here negative 1, multiply by negative 1 half, then add to second row, so we'll obtain here 2, multiply negative 2 by negative 1 half, then add to 0, so we have here 1, again add third row to first row, so just we have here 0, 3 plus 0 equal to 0. Here negative 5 plus 1 equal to negative 4. Here negative 2 plus 0 equal to negative 4. So here we just convert matrix A into identity matrix, and this part of augmented matrix is the inverse of matrix A. So just clear all of that, and here x x equal to inverse of matrix A and matrix B. So we'll have here 3, negative 4, negative 2, here negative 1, 2, 1, here 3, negative 5, negative 2, and 2, here 4, negative 15, 40. Okay, this multiplication will obtain that here in first row negative 5, here we have 5, and here we have 10. Then x1 equal to negative 5, x2 equal to 5, x3 equal to 10. Okay, so simply and one step to convert matrix A of coefficient of x to inverse matrix of A, then multiply this matrix by matrix B of the free terms in system of equation. Okay, I hope these two methods are clear of Gauss Jordan reduction method and inverse matrix method to obtain the solution of linear system. Okay, thank you for watching and stay tuned for the next lecture.